All right, so I wanted to go over just really quick the adding and subtracting polynomials for you guys, just in case you forget or you weren't able to tune into the Zoom before. So the assignment that I gave you, I had assigned the evens on this paper. So what I'm going to do is I'm going to take a look at a few of them just to give you kind of a run through on what you might be expected to do or how to do some of these. So the first one I want to start with, maybe let's take a look at number 4 on this paper. Number 4 is 7z cubed, it's an ugly z, plus 4z minus 1 plus, and then the quantity 2z squared minus 6z plus 2. And what we learned with this, because we have two trinomials here that are being added to one another, rather, in this case, is we need to get rid of these parentheses before we can start just combining things around. And the method that I told you guys to kind of help you out with this stuff is, you know that when you have something in front of the parentheses, we should distribute it in. Well, we don't really see anything in the front here, but we do have something in front, and it's just a 1 in this case. In front of these parentheses over here, we have a 1 that we just don't typically write in mathematics. And I could distribute that 1 in, and that could get rid of those parentheses. Now, keep in mind, we're only doing this because we have this plus or minus sign in between. I'm adding or subtracting these polynomials from one another. So let's go ahead and distribute this 1 in. When I multiply anything by 1, nothing changes. So 7z cubed stays 7z cubed. 4z stays as positive 4z, and negative 1 stays as negative 1. On the other side, I've also got just a positive 1 here that I can distribute in. So I take my positive 1 and I distribute it to each of these. Again, when you multiply by positive 1, nothing changes. So 1 times 2z squared is still just a positive 2z squared. 1 times negative 6z is negative 6z. And 1 times 2 is still just 2. Long story short, you're going to see the more you practice this stuff and as you get used to this, when you have the plus sign in between parentheses, it's almost like those parentheses aren't really there. Be careful with that, but for us here in Algebra 1, for the most part, that's kind of true. Now, once you get down to this point, where you just have one expression, one big polynomial, now we can start combining stuff. So we want to find all the things that have like terms and put them together. For the 7z cubed, nothing else here has a z cubed on it, so I can't combine it with anything. So I'll just go ahead and write that down here on its own, z on x. For the 2z squared, we'll go to that one next, because proper writing a polynomial, we go in standard form, which means from biggest exponents to smallest. So I want the cubed term first, then the squared term, then the one that's just got to the power of 1, and then the one that doesn't even have a variable at all. So for the 2z squared, again, no partners. There are no other terms here that have a z squared. So I'll put this one next. It's all alone as well. Next, we would go to the power of 1 terms, which I have a 4z, and I've also got a negative 6z. I can combine those. 4 minus 6 is negative 2z. And then last but not least, my regular just numbers here, my constants that are all alone. Negative 1 and positive 2. Negative 1 plus 2 is just positive 1. So here we have our final answer, simplified, 7z cubed plus 2z squared minus 2z plus 1. That's for number 4. Additionally on this, I gave you some that were polynomials that are being subtracted from one another. So let's take a look at number 8 here as well and see what we can come up with when there's a subtraction sign between these polynomials. Number 8, 6x cubed minus 4x squared plus x minus 9 minus, and we've got 3x squared plus 7x plus 3. So it looks like we've got a lot here, but because we have this minus sign between them, we're subtracting these polynomials. Again, we just want to look at what's in front of each one and distribute it in. In front of the first polynomial, I've got a 1. I don't write it, but it's there. So we can distribute the 1 in to everything, and that'll get rid of the parentheses. Again, remember from the last problem, if you distribute a positive 1, nothing changes. So here, nothing changes. 6x cubed minus 4x squared plus x minus 9. For my other one, however, I'm distributing a negative 1 this time, not a positive 1. When I multiply by negative 1, the signs change. For example, negative 1 times positive 3x squared gives me a negative 3x squared. Negative 1 times positive 7x gives me a negative 7x. And negative 1 times positive 3 gives me a negative 3. So now I have this all written out as just one large expression, one big polynomial here. Again, look for things that can combine. And we're going to start with the biggest exponents once again. So x cubed is my biggest. There are no other x cubeds in this whole polynomial, so it stays alone. Just write it, 6x cubed. Next, let's move on to the x squareds. And I see I do have one. So negative 4x squared and negative 3x squared, we can combine those. Those go together. Negative 4 minus 3 is negative 7. And then I still have my x squared on it. For my x terms, looks like I do have a pair of those. So positive x minus 7x is negative 6x. That's 1 minus 7 to give you negative 6. And then last but not least, our numbers. So we have negative 9 and negative 3. Negative 9 minus 3 is negative 12. Here's our final answer for number 8. And now the other one that I'd like to go over here is a problem like number 14. There's a lot involved in number 14 because we have not just parentheses, but we've also got brackets. So we kind of have parentheses within parentheses, multiple times that we're doing this adding and subtracting of polynomials. So for number 14, let's take a little look. Number 14, we've got 7x minus, and now here's where we've got brackets, 2 times the quantity x squared minus z plus 4x squared minus 7z. I've even got multiple variables in this one. And then plus 6z squared. So again, we're adding and subtracting polynomials here. There's a subtraction sign between this monomial and this large polynomial, and then another addition sign with the other monomial here. First thing that I'm seeing to do, well, we can take care of this number that's in front of some parentheses within the brackets. So let's distribute that, the 2 to each of those, the x squared and the minus z. Nothing else is changing. I'm keeping everything else exactly like it was. So the 7x is coming down, the minus sign's coming down, the brackets are even coming down. 2 times x squared is 2x squared. 2 times negative z is negative 2z. And then all this other stuff, I didn't do anything with it, so just keep it coming down. Just write it down below. Plus 4x squared minus 7z, close out the brackets, plus 6z squared. Didn't change anything at all there. And now we have a problem like we saw before. I've got a monomial. I don't have to do anything with it because there's no other things. I don't distribute anything to this. And then here I've got this big polynomial, but it's got a minus sign in front of it. We can distribute that thing that's in front to everything inside. So let's do that. We'll take this -1 and we'll distribute it to all of this stuff that's in those parentheses. 7x, didn't do anything there, it stays. -1 times 2x squared is -2x squared. -1 times -2z is +2z. -1 times 4x squared is -4x squared. -1 times -7z is +7z. And then over here, this +6z squared, again, I didn't do anything with it. There's no anything to multiply it with, so just keep it alone here, +6z squared. And again, now you notice we've worked our way down to a point where I have no parentheses, no brackets. It's all just single terms as part of one large polynomial. We can combine our like terms. In this case, if you're starting with the biggest variables or the biggest exponents on your variables, you kind of have a choice. You can choose to either start with the biggest z exponents or the biggest x exponents. I'm going to start with the biggest x ones and work my way down in terms of the exponents on x. So we'll start with our x squareds. X squared is the biggest exponent on an x. And I do have two of those, -2x squared, -4x squared. When I combine these, I get -6x squared. Next, I would have an x with a 1 on it, and I just have one of those. There's no other terms here that only have x to the first power. So this guy, he's just sitting at his table all alone, a +7x. And now I want some terms that have no x on them. Well, that's all of these. So it doesn't really matter what order I put these in. I'm going to start putting them just in increasing order of z. And you might start seeing why I might do that as we get into factoring a little bit later. But we'll start with our z to the first power. So let's do 2z plus 7z. This will be 9z. And then my 6z squared is all alone, 6z squared, and it's positive. So this is our final answer for these. Now, one thing that you can keep note of here is it took me a lot of work to get there because I'm showing all of my work. And I think if you show all of your work, if you take things just one step at a time, do your little distributions just on their own, you're a lot less likely to make any mistakes because you're keeping track and you're keeping organized. Plus, when you turn things in for me, then I could really spot where you're messing up, if you're messing up at all. So good luck, guys. Finish this assignment up. Submit it via Google Classroom. Just snap a picture of it. Go to add, upload your file, that sort of thing. I'll take care of it, and have a good one.